Welcome to Principles of Corporate Finance video lecture series. Now on session 5, we continue to time value of money concept. So in previous session, we talked about present value, future value, generalized formulas. Given 3 of parameters in formula, we found 4th parameter. For example, if we have future value, present value, and time, we calculated the rate and others. Now we continue to compounding periods. All examples so far have assumed annual compounding, but in practice, banks compound interest quarterly, monthly, or daily. Mortgage companies compound interest monthly. So these compounding periods may be different than annual rates, but all rates are quoted as annual rates. Frequency may be different than annual frequency. If rate is quoted annual, but compounding is different than annual, that's less than annual frequency, maybe monthly or weekly or other semi-annual, then effective rate, real rate, that's felt rate will be higher than quoted rate. This felt rate is called effective annual rate. In other words, if the rate, compounding rate, is less than annual rate, it's monthly or daily or weekly, we convert this rate into annual rate and call it effective annual rate. Effective annual rate is annualizing rates that is quoted other than annual rate. So compounding an investment m times a year for 2 years provided for the future value of both present value times 1 plus rate divided of number of periods to the power of number of periods. For example, if you invest $50 for 3 years at 12% compounded semi-annually, your investment will grow to 50 times 1 plus rate. We have 2 semi-annual periods in a year, divided by 2, power of 2 times 3. So that is total number of periods. We have 3 years, and we have 2 semi-annual periods in a year. We have total of 6 semi-annual periods. 50 times 1.06 to the power of 6, that is $70.93. Our $50 will grow to $70.93 at 12% compounded semi-annually. So one semi-annual rate is 6%. This 12% is annual percent, quoted rate is annual rate. One semi-annual period is half of this. A reasonable question to ask in the above examples: what's the effective annual rate of interest on that investment? That is future value. The effective annual rate of interest is the annual rate that would give us the same end of the investment worth after 3 years. We can only calculate effective annual rate as that is rate 1 plus quoted rate divided by number of periods to the power of number of periods in a year, and we subtract 1 to get the effective annual rate. Assume we have $1,000 of investment. We want to invest this amount into a bank, into a savings account. We have 3 banks. Bank A offers, for example, 12% compounded monthly. Bank B offers again 12% compounded semi-annually, and Bank C offers 12% compounded daily. So which one is the best option for investing our 10,000? Since they have the same rate but different compounding period, the final amount will be different. We cannot say that the rate is same, the amount will be same. No. As I said, this period will change the final amount. For option A, our 1000 will grow up to, that's 12% monthly, divide by how many months do we have in a year? 12. And we have 12 months in a year. So this amount will be 1126.82. Our option B is about 1000 times 1 plus, it is quoted 12% but compounded in semi-annual periods. So 12% divided by how many semi-annual periods do we have in a year? That's 2 to the power of 2. Our final amount will be 1123.6. And our option C is future value at the end of 1 year will be 12% divided by daily. We have 365 days in a year to the power of 365, and this will be 1127.47. So at the end of year. So since we are at investing side, we are investing our amount in savings account, we are looking for the highest rate. In these options, this is third option, third bank. This is the higher than other options. So rate is same, but the most frequent period earns that yields higher final amount. So it is because if it goes to more periods, our final amounts increases. Effective annual rate, if you are looking at the rate, that is 1 plus quoted rate or stated rate. In our example, it was 12%. We divide by number of periods to the power of number of periods minus 1. Here we get the rate. For example, for our effective annual rate, for our option A, it is 1 plus 12% divided by 12 to the power of number of periods. That's 12 minus 1, and it is 12.62. 12.68 percent. But the quoted rate was 12%. 12%. Effective rate is higher than quoted rate. Quote rate is, they say that we earn you 12%, for example, annual. Since compounding at monthly frequency, it is higher than quoted rate. For option B, it is semi-annual, 1 plus rate divided by quote rate divided by semi-annual. We have 2 semi-annual periods in a year, we put here. And to the power of 2 minus 1, it is 12.36%. And effective annual rate for option C is 1 plus rate divided by number of days, number of periods in a year is 365. To the power of 365 minus 1, 12.74%. So this is rate part, and this is future value part of this investment. Effective annual rate, sometimes this approach may confuse borrowers. For example, they say that we lend you at 12%, but compound monthly. So it is clear that it will be higher than 12%. If you go and borrow at, you assume that you are borrowing at 12%, but actually effective rate is higher than this rate. That's why central banks require financial institutions to release effective rates, to release how much will the final cost to the borrower. Find the effective rate, annual rate of an 18% APR, that's an annual percentage rate loan that's compounded monthly. What we have is a loan with a monthly interest of 1.5%, that's 18% of APR. The monthly rate is 18% divided by 12. This is equivalent to a loan with an annual interest rate of 19.56. If you calculate it this way, effective annual rate equals 1 plus rate divided by number of periods to the power of number of periods, 1 plus 18% of APR divided by 12, that's because of monthly payments, to the power of 12, and this is 1.19. If minus 1, we get the rate 19.56. So banks state that we lend at 18% APR, but applying some finance knowledge, we know that it's higher than if you borrow at this rate. Actually, you are borrowing at 19.6% rate annually. Some financial institutions compound at high frequency, for example, they said that daily. They may even compound hourly, even per minute, or even secondly, and it may go to continuous compounding. General formula for future value of an investment compound continuously over many periods can be written as future value times present value times e to the power of r and t. So e is a constant that's approximately equal to 2.7. So this is effective annual rate calculation. We have some patterns in our cash flows. If we see these patterns, and we can easily find present value or future value of our cash flows. One is perpetuity, a constant stream of cash flows that lasts forever. For example, we said that if we have multiple cash flows, for example, cash flow 100 here, 200 and 2.500. So if we require to find present value of these cash flows at, for example, 8% rate, what we do, we find present value of all these cash flows one by one and sum up all. Present value at 0 is 100 divided by 1.8 plus 200 divided by 1.8 squared plus 250, 1.08 to the power of 3. So finding present value of all these numbers, let's say it's about 470, for example. We find present value of these cash flows, finding all single cash flows one by one. Or future value. Assume we invest 200 today, 500 next year, and 400 next year. How much will we have at the end of third year? That is, we find future value of all these cash flows one by one and sum up all these numbers at the end. 200 times 1.08 plus $500, 1.08 square, plus and 400, it earns interest for 1 year, 1 period, and that's, I put 1 here. So this is future value of all these cash flows. If cash flows last forever, we call it perpetuity. For example, this may go to forever, or sometimes we have fixed cash flows. Assume that you have constant salary, you know your expenses, and you decide that every month you can invest in $50 into your savings account. $50, $50, $50 and $50 every month. So you want to know how much will you have at the end of 4th month. you get the rate of 1% per month. I put random numbers. So how we can calculate this? We calculate future value of this 50 for 1 to 3 periods. $50 of future value of this 50 for 2 periods. Future value of 50 for 1 period, and this $50 itself. We add up all these numbers and get our final future value. But here we see there is a pattern, there is some fixed structure here mathematically, 50, 50, 50, 50, and period is monthly, 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 monthly. Since there is a pattern, we can easily calculate future value and present value of these numbers. We call this type of cash streams annuity. Annuity is a cash stream that the cash payments are fixed and period is fixed. If these cash payments are fixed, 50, 50, 50, and the period is fixed, monthly, first month, second month, third month, and the last month. So frequency is fixed, cash flow is fixed. We call this type of cash flows annuity. And it makes easier to find present value and future value of these cash flows. Future value of an annuity is calculated with a formula as payment here times 1 plus rate power of n, that's number of periods, minus 1 divided by r. So applying our formula easily, we can find future value of these $50. Also, we can find present value of annuity. Assume that there is an investment that will earn you $120 per year for 5 years. So what's the present value of these cash streams? Our previous way was that finding present value of this cash flow for 1 year plus finding present value of this cash flow for 2 years, 3, 4, 5 years. Let's assume rate is 1% again. Again, we see fixed payments here. There's a pattern, mathematical pattern, and the payments are all monthly payments. Then we understand that this is annuity. And we are required to find present value of annuity. Applying present value of our annuity formula, that's payment times 1 divided by rate minus 1 divided by rate times 1 plus rate power of n. And we find present value of all these annuity. If these payments go forever, for example, and this is called perpetuity. Perpetuity is a cash stream that goes forever at fixed cash flow. Present value of perpetuity is very simple to calculate. That's 100 divided by rate. As I said, it's a constant stream of cash flows that lasts forever. Some perpetuities may grow year by year, that's not constant. So we need to make some adjustments to our formula, you'll see it. And annuity is a stream of constant cash flows that lasts for a fixed number of periods, and as I said, as it says here, cash flows are fixed, constant. Annuities may grow. Applying a very simple adjustment, we can find our present or future value of these cash flows. Cash flows go forever for nth period. This is perpetuity. Finding present value is finding present value for these cash flows one by one. Applying algebra, we find this is cash flows divided by rate. For example, we have an example here. What's the value of a British console that promises to pay £15 every year forever? Appropriate rate is 10%. 15 pounds, 15 pounds, 15 pounds, it goes forever. As long as you keep this, you pass it to your son, to your grandson, and others. So that's 15 divided by 10%, that's 150 pounds. Present value of all these cash streams, cash flows is 150 pounds. As I said, these perpetuity may grow from year to year. For example, here it is C itself, it grows at G rate, G square, and it goes forever. And present value of these cash flows is cash flow, first cash flow divided by R minus G. R is required rate, that's interest rate, G is growth rate. An example we have here, expected dividend next year is $1.3 and dividends are expected to grow at 5% forever. So expected dividend next year, C1 is 1.3 and it grows at 1.5 forever. If the discount rate is 10%, what's the value of this promised dividend stream? That's what's the present value of this stream? That's 130 divided by R minus G, 10 minus 5%, and it's $26. $26 is present value for these cash flows. And I will say this present value of future cash flows of any financial asset is value, price of that asset. Coming to our annuities, a constant stream of cash flows with a fixed maturity. C is constant and it has a maturity, fixed maturity T. It may be 5 years, 10 years or others. And finally, present value for all these numbers, with small simplification, we get present value as C divided by R times 1 minus 1 divided by 1 plus rate to the power of T. This formula is the same as I wrote, that's just a rearrangement of formula. And all mortgage payments, auto loans are annuities. If you can afford $40 monthly car payment, how much car can you afford? If interest rates are 7% on 36 months long. So you may pay 40, 63 months, and the rate is 7%. As I said, all rates are quoted annual. Our payments, since our payments are monthly, we need to convert this annual rate into monthly rate. That's 40, apply our formula. This formula, C here is 400, divide by rate, 7% annual rate, we divide by number of months, get monthly rate, times 1 minus 1 divided by, and the formula we get 12.9 thousand, around 12.9 thousand. So with this payment schedule, we can buy about 12.9 thousand car. There's another example. What's the present value of a 4-year annuity at 100 per year that makes its first payment 2 years from today if the discount rate is 9%? So that is, we have 4-year annuity, it starts its first payment 2 years from now. We are, by default, we are on time 0, it starts on second year, 100, 100, 100, and 100. What's the present value of this cash stream on time 0? You see, we have 100, there's a pattern, this is annuity. If we find present value of these cash flows, it will come to this. So present value calculations on our timeline takes all numbers to previous period, to one period before. 100, 100, 100, 100. Final present value of this cash flows, it is 323.97 on 0.1. So present value is calculating the discounting back. taking all this number back, applying our annuity formula, we get 330. Since we are on time 0, we need to bring back this number. We need to rediscount back this 323. So it's on time 1. We again discount back to time 0, divide by 1.09. We get 297.22. So present value of $100 for $100 starting on second year is 297.22. Here it is calculated as this way. I'm saying it again. We discounted 100. It is 323.97, and it comes to 0.1. It comes to one period back. From here, it comes to here. It's a lump sum. And to find present value for these numbers, we again discount it back one period and get this number, 297.22. As I said, all mortgage payments, auto loans, bank loans are examples of annuity. A growing stream of cash flows with a fixed maturity. So these cash flows, annuities may grow from year to year. For example, in year 1, it's this amount, and for coming years, it may grow at G rate. So again, the principle is same. All we do is find present value of this cash flow, C divided by 1 plus rate, C times 1 plus G divided by 1 plus rate square, blah, blah, blah. So if we rearrange this, applying some mathematics, we get this as C divided by R minus G and get this formula. Here we have an example. A defined benefit retirement plan offers to pay $20,000 per year for 40 years and increase the annual payment by 3% each year. So it starts paying you $20 per year, $20,000 per year, and increase it 3%. What's the present value at the retirement if the discount rate is 10%? So you get 20,000 in year 1, next year it goes 3%, next year it goes 3, and for 40 years. Obviously it's a growing annuity. Applying our formula, we get 265.1 thousand. It's around 265.1 thousand. So annuities are, as I said, annuities are more used, more seen category in finance, and loans, mortgage, auto loans, and all loans are examples of annuities. Here we will talk about loan types and loan amortization. First type is pure discount loans, are the simplest form of loan. The borrower receives money today and repays a single lump sum at a future time. An example for this is treasury bills. For example, $1 million treasury bill is sold at discount. You pay, for example, 9.9 thousand. I put random numbers, and at the end of the period, you get 1 million. Interest-only loans require an interest payment each period with the full principal due at maturity. So, an example is bonds. If you issue a bond, you pay interest coupon payments per period. At the end of the period, you pay out principal amount. Amortized loans require the payment of principal over time in addition to required return. That's you borrow some amount and you pay back fixed amount. This amount includes part of your principal and interest. Amortized loans, consider a 50,000 10-year loan at 8% interest. The loan agreement requires the firm to pay 5,000 in principal each year plus interest for that year. With this condition, we can amortize our loan as this one, beginning balance. We may have different schedules, but the best schedule is this one. beginning, interest, principal, total, and ending. So beginning balance for year 1 is 50,000 and rate is 8%. 8% of 50,000 is 4,000. We pay fixed amount of 5,000. So it means that we total pay 9,000. Our ending balance is 45,000. We paid 9,000 in total, and 5,000 of this payment is principal payment. We have 50,000 at the beginning. We paid 50. The remaining balance is 45. 45, and again, interest is 8%. 8% of this amount is 3.6 thousand, and we pay principal 5,000 from 45,000. Ending balance is 40,000, and total payment is 8.6 thousand. If we continue this at the end of the period, our ending balance will be 0. This is a sample of loan amortization. We amortize our loan and it comes to 0 in 10 years. So ending balance goes down 5,000 each year, and our total payment decreases also, but principal payment is fixed. We talked about present value and future value. Present value is an important concept in corporate finance because almost all financial assets are valued through present value approach. We say that price or value of any financial asset is present value of its future cash flows, expected cash flows on these financial asset. So if we want to value any financial asset or even a firm, a company, we find future cash flows, expected cash flows from this company or from this asset, and find appropriate discount rate for these cash flows, of course considering risk and other factors, and finding present value of these expected cash flows on that rate is value of price of that financial asset of or a company. Conceptually, a firm should be worth the present value of the firm's cash flows. The tricky part is determining the size, timing, and risk of those cash flows. Of course, this firm company valuation is a different topic. It has very details about size of cash flows, as it says here, timing and others. You can solve time value problems in any of 4 ways. Mathematicals, we may have formulas, tables, and financial calculator, and spreadsheet software. Microsoft Excel has all details to solve time value of money formulas. If we go to formulas, and go to financial formulas, we can see that there are many formulas for finance, and we have future value formula, we have present value formula, and all formulas. With a few formula, we can find future value of a single cash or annuity. With PV formula, present value formula, we may find present value of single cash or annuity. We have rate here. We put in a number of periods. Future value, we get present value of single cash, or if we put in payments and other indicators, we get present value of annuity. So Excel has all details to find present value, future value of cash flows, and do all other financial calculations. This is a general summary about time value of money. In session 4, we talked about present value, future value calculations of single and multiple period cash flows. In session 5, I talked about effective annual rates, that rates may be quoted other than annual rates. we converted it into annual rate that we call it effective annual rates, and we talked about loan types, annuities, and amortizing loans. This is the end of session 5. Thank you for watching.